Hi, everyone. My name is John. I work in Google Checkout. And we have a speaker today. His name is Frank Cohen. Someone from my team had told me about some of the work that Frank was doing and said we should definitely have a talk on his topic. And I said, why? I mean, we have so many talks on testing. Why have another one? And the specific introduction that David, the person who introduced Frank to me, gave was one of the reasons I'm actually here today. And I said we should have this talk. And that is, Frank's going to talk a little bit about some of the software that he's written. It's a company that's based on the same product. It's called PushToTest. And you could say I'd like to use the word magic, but then that'd be giving away too much of the stuff that Frank's going to talk about anyways. And what it really is using unit tests to create functional system and performance tests. And that's something that's really nice because you can leverage work that people have already done or going to do to create larger and broader tests. So I'll let Frank take the floor. Go ahead.
All right. Thank you, John, for that nice introduction. I hope you can all hear me at this level. Can you hear me now? Yeah, there we go. Thank you very much for having me here, John. PushToTest has been around for about 5 or 6 years now. We got started when I was at Sun Microsystems building the Sun Community Server, which is a kind of multimedia system that allows distributed groups of users to be able to share information back and forth in a very secure way. That information could be like a spreadsheet, it could be email messages, it could be voicemail messages. It was multi-protocol. The problem at the time was to try and test and validate that the community server was ready to ship, like a new version was ready to ship, required us to be able to validate that all those different protocols would work. At the time, Mercury Interactive was still kind of getting its act together around Load Runner, kind of understanding what the web was, let alone trying to figure out all these different protocols that were showing up. What we saw at the time was that not only were they expensive, but they didn't support what we as developers needed. And I couldn't get anybody to sign the PO at the time. So I wrote a piece of software which became TestMaker. A friend of mine convinced me to open source it. It's currently licensed under the GPL version 2. We're making plans to go to version 3. The software is used by about 140 or 150,000 software developers, QA technicians, and IT managers. And it's gone through 4 major architectural revisions. And what I've brought with me today is TestMaker 5, which will hopefully ship tonight. In that we've already gone through a couple of release candidates, and it looks like everything is good to go. The company PushToTest is basically 5 people working full-time. We're not VC-backed. We basically make our money by providing commercial licenses to the TestMaker software, the PushToTest TestMaker software, and then also by providing consulting services to companies large and small. General Motors is our largest customer, and then the smallest is a 1-person shop 2 cubicles away from mine. We're very much kind of an open source player with no expectations of what the needs are going to be of our users. The TestMaker framework, which I brought up here, is delivered as a Java Swing-based application, and it provides users with a way to be able to build unit tests in a variety of different languages, and then automatically run those unit tests either as functional tests, as load tests, or scalability tests, and also as service monitors. So there's kind of like 3 different types of customers that are different types of users of this software. There's kind of software developer who really knows objects, really knows scripting very well. Then there's a QA technician who has to write a load test or a scalability test or in some way validate a release, and really probably doesn't have any programming experience. And then there's the IT manager who really is just, their boss, typically the CEO, is using the IT manager's neck as a throttle to identify scalability and performance problems that the end users have. So the IT manager just wants to make sure, are my users satisfied? And oftentimes they don't have any technical background. So what we've done is to create a test environment. I love when that happens. It drives the guys behind this curtain nuts, I'm sure. So what we have is a utility that works for all three of those groups, the software developer, the QA technician, and the IT manager. And I'll just show you a few examples of this. The basic environment is delivered as a swing-based Java application. It's 100% Java. It runs anywhere Java runs. The environment itself has basically a simple set of tools to allow you to create tests. For example, let's say I wanted to build a test of a web application. We include the TestGen for Web plugin to Firefox that allows you to basically visually use a web application. So I've got one here, examples.pushtotest.com. And being that networks sometimes are not, oh, there it is. So with this up, notice here I've got a new toolbar. It's basically an add-in to Firefox. This is the TestGen for Web one. It was originally developed by our friends at SpikeSource. It's maintained somewhat so-so by them. It's maintained very well by us. In it, I can tell it to start recording. If I use this simple web application, which has some links in it, some web forms that I can type in. Type in my phone number. Type in an account number. Say transfer $100. This application is just a simple example app that we host on the examples.pushtotest.com site, just so that people have something to learn the TestMaker environment from. While I was doing that, the TestGen for Web plugin was watching my activity. And then if I wanted to play it back, I can click here, and it will take me back to that original page that I viewed, and then take all of the actions that I did before, namely to click in a certain location within the application to type in the information that I did into that web form. It works just fine with Ajax applications, so we've tested it on like maps.google.com. I think this is telling me an alert because of the network connectivity. So what I'm going to do is, instead of using the network, I'll just use the local version that we've got. And I'll do the same thing. Let me just reset this. Okay. I'll say record. I'll go back to the default page. Click here, file 2. Here's my information. I'll tell it transfer, tell it record. And now when I say stop and play back, this is going back to the original page, and then it'll navigate over to the other page. It'll type in the information it wants. So simple record and playback function. The functions that it's recording are in this format. It basically has a very simple, like XML way of representing that unit test of that web application that I just recorded. Here it is a go-to action. Here are the various clicks. Notice that it's using XPAD expressions to be able to validate the various information that it's getting within the DOM of this web application. When I tell it to save, it'll save this in an XML file format that we can now use within the TestMaker environment. Let me just close these things. I will navigate over to TestGen for Web examples, and I will take a look at this file, which is the XML of that test that we recorded. The XML here, I'm not sure if you can see it, hopefully you can. Here's that go-to command that tells it to go to the first page. Here are the XPath instructions for doing a click within the DOM. All of this means that as a kind of QA technician or somebody who doesn't know how to program, I could build a unit test like this of a web application, and I'd be able to run it within the TestMaker environment. One of the other things that we do is allow you to import this unit test instead of as as an XML file. Let me just navigate over. Here's the test gen for web examples. Here's that unit test. And now I'll tell it, output this as, instead of an XML file for simple playback, output it as a Jython script. So in this case, we've created a PushToTest TestMaker has created a Jython implementation of that same unit test. So now that it's in Jython, I'm using the HTML unit framework. So here's a typical unit test, right, like a JUnit test case. It implements a setup, a teardown, and a test method. Within the test method, I'm instantiating the HTML unit framework, and then I'm able to step through step through the same unit test. Just now I'm using the HTML unit framework as implemented in a Jython script. So what we find is that a lot of QA technicians might not code, but they want to code because they see that as part of their career path. You know, it might be an enablement for them to get into development someday. The Python language tends to be a very friendly, straightforward language because while it does give you an object framework, it's very procedural at first. And because of the spacing of Python, it becomes very easy to kind of teach a QA technician how to write these kind of scripts. So the PushToTest TestMaker environment acts as this kind of like friendly framework for you to be able to move from just record and playback using a web application into writing real unit tests and real object-oriented tests. So what you can do with this test is a number of things. We provide an environment that we call test scenarios, which is an XML document that allows you to reuse those unit tests as functional tests, as scalability tests, or as service monitors. So I can click on new load test, for example, and it will create an XML document of the test scenario. But I have one already in here. It's kind of like a cooking show in that respect. So here's the same. Sorry. There it is. Here's example agents, test gen for examples. So here is a functional test. I've opened that test, and a controller panel appears here. If I want to see the controller panel close up, I can expand it into its own window. A controller panel here represents that XML document in a graphical way. The XML document, the test scenario, gives the TestMaker environment everything it needs to know: where to run the test, how often, what unit tests are going to be called, in what order. Basically, it's all represented in that XML document. But what we find is that a lot of kind of QA technicians and IT managers, again, they're not technical, so they need more of a graphic environment. So this is the graphic face of that test scenario. This controller panel lets you run a test, pause or stop, edit the test, and then close it. There is a horizontal slider here, which I'll show you how useful this is in a scalability test in just a second. And then the results appear down here. So if I wanted to run this functional test, I just click on it. The status says it's now running this test on a set of test nodes. Because the push-to-test framework is a distributed test environment, by default, it's going to run on the test nodes that's on my local laptop. But if I wanted to run this functional test from, say, Sydney, New York, and London, I can install test nodes at those 3 different locations and run this functional test remotely with TestMaker, this framework acting as the console to it. So what it's done here is tell me, yeah, it's run this successfully, meaning no exceptions were thrown when it ran that unit test. And if I scroll down here, this is like a little console output window. What it did was it said, yeah, the test is valid. It said the test is running. It loaded in the resources that we told the framework would be needed to operate the test, namely those unit tests. It validated that the test nodes were ready to run, and then it ran the test. And because this is a essentially a unit testing environment on steroids, right? Unit tests just operate, and they operate very quietly unless something goes wrong, in which case an assertion of an exception is made, and then the TestMaker environment would show you where the exception is. So remember before I said that this panel is representing an XML document. Let me show you what you can do within that XML environment. So I clicked on this, this button here, which opened an editor. And can everybody see the text in here? Or maybe I should say who can't? That's why I'm wearing these things, you know. OK, so the way that the test scenario document works is up on the top. It says, hey, I'm a test scenario, right? And then immediately, it gives you some basic information about that test scenario, like namely the name of the test, and then where the default directory is going to be found. The next element here is test nodes. A test node is a distributed operating environment. And in this case, we're just running on the local host, my local laptop, which is fine. But like, let's say I wanted to run it on a bunch of different machines. You could tell it, hey, run this on the 40 machines that you've got in a rack of servers, for example. Run it concurrently, and then tell me how each one of them performed. Next is a set of resources that this test needs to operate. So you remember before when I was using Firefox, I identified the name of the file that we're going to save that recorded test to. Well, here it is. So this is telling the test framework that when the test is sent to the test nodes, these are the resources that are going to be needed. So the resource in this case is a testgen for web file, but you could also send a jar file that might have your existing objects that you've written. You might send another XML file which would do configuration for the test while it's operating. You might send a comma-separated value file if you wanted to input data dynamically at runtime. And what TestMaker is going to do is make sure that all of those resources are sent to the test node at test operation time. So there's no more like, oh, did I configure all these test nodes correctly? Did I FTP the resources that are needed? TestMaker takes care of that for you. The next area within the test scenario document then defines that this is a functional test. Functional tests in our nomenclature mean that a test is just going to go from top to bottom and operate once. It might operate several unit tests along the way, but there's only one path through it. So in this case, we identify a test case. There are use cases that we identify. And over here, let me just drag it over a little bit so you can see. Over here is a run method within the test scenario that says, find the test class that I identified in the resources section, and call the testgen for web method. And the language type in this case is going to be testgen for web. Right? So if I wanted to run multiple unit tests, I just insert multiple run elements within this test scenario document. Likewise, it's fully aware of unit testing. So if you have a separate setup or teardown method, you can put that within the test scenario to say, before the test runs, operate this setup, and then after the test runs, operate this teardown method. One thing I should point out is the language type here. The testgen for web runner is one of many runners that PushToTest includes. So if you wanted to write a test in Java, the language type would be Java. If you wanted to write it in Ruby or Groovy or PHP or JavaScript, there's about 15 different languages that PushToTest supports. That's because we've been proponents and longtime supporters of scripting on Java, and now Java 6 features the JSR 223 script engine API. So there's about maybe 15 or 20 different languages that are supported. Any language that you want to choose then can be operated on within the PushToTest framework. So if you want to write your unit tests in Groovy, no sweat. There's even example code in here that shows you Groovy. Same thing for Ruby and all of the others that we support. OK, so the last thing to show is in this test scenario document is that there are various options for controlling the timing of the test. But that's about it. So when I operated this test, it ran that test, that unit test that we recorded in TestGen for Web once. And that's about it. So you might say, well, that's great, Frank, but can it do anything else? So let's say we wanted to run that same test, but instead of just in one thread, one time through, we wanted to run that same recorded unit test as a scalability or a load test. So I'll open up this XML document, or this test scenario document. And here it is. And what I'll do is I'll get it started operating just because there's a little bit of setup time involved. And then I'll describe what's going on. The controller panel looks a little bit different for this in that it's now showing me status of the test node. So load tests typically will operate on multiple nodes. Right now, I'm just using the local node. Notice it changed to green, meaning that it's ready now. It's received the resources it needs. It's ready to operate the load test. And now it'll start making requests out to that target host. The horizontal slider here is showing that we're going to be testing first at 10 concurrent requests with a message payload size of 1. Then as the test proceeds, you'll see this horizontal slider go from left to right as it steps through the various levels of concurrency that's being tested. So concurrent requests in the push-to-test framework are analogous to threads. Essentially, the push-to-test environment will instantiate a certain number of threads, operate that test for a certain given fixed period of time, then take down those threads and operate at the next level of threads. So in this test case, it's instantiated 10 threads, and it's now operating that unit test over and over again within each of those 10 threads. So as you bump up, say you go from 10 to 20 to 30 threads, one might expect in a linear, a system that has linear scalability that you'd go from, say, 1 transaction per second to 2 to 3. That's the whole point of doing this kind of scalability testing. We're able to rapidly show within this graphical environment what the scalability index of the target host looks like, and therefore provide information to the user about how many servers they need to buy, what kind of network bandwidth they need to buy, how many CPUs to buy. So this is showing you a live view of the test. Currently, it's not a speed demon on the Wi-Fi here, so we're getting 0.017 transactions per second. This test will operate for, I think it's 2 or 3 minutes. If we wanted to change the test, so let's say you're testing at 20 different levels of concurrent request sizes, and you get through about half of them, and then you realize, oh, I really want to skip ahead, or I want to go back and try and rerun it. That's where this scroll bar comes in. So notice when I'm over here, it's testing at 10 concurrent requests, and if I scroll over here, it goes up to 20. So this means that I could drag over and now stop the 10 concurrent request level and move on to the 20s. With other even commercially available tools, you really have to let the test tool run its course. And there's no way to, once a test starts, to be able to make a change like this. Once each of the tests is completed, push-to-test will provide you with a distribution chart. So this is showing you how many milliseconds it took for each of the transactions that were completed for the duration of that test. And so this would be 10,000 milliseconds or 10 seconds, 20, 30, 40, 50. And so you can see that most of them started here at 30, and then we saw a decrease in performance, most likely of the network, that went up to 50,000 milliseconds or 50 seconds. It's now operating on the second level of concurrent request levels, and you'll see that appear here as it progresses through the test. At any time, we can pause, of course, or stop the test. But let me give you a little bit of insight into what's going on at the test scenario level. I clicked here, and it opened up the test scenario document. So here is the XML document for a load test. Right? So it starts with a test scenario. Again, we have the basics information. Then we have where it's going to run the test, on which test nodes. Then we identify which resources are needed. And now instead of saying a functional test, it's saying this is a load test. Load tests have different dimensions than a functional test. For example, here is how we set the concurrent request level sizes. So if I wanted to change this to give me a number of other concurrent request level sizes, I just add it here. And then the TestMaker framework worries about staging and orchestrating that test. Below, we've got the same test that we recorded with TestGen for web. Here is the run method. Here's the run method of this test, which is calling that TestGen for web recorded unit test. Right? So I didn't have to do any programming at this point to go from essentially a functional test to a scalability and load test. I just had to change the parameters of this test scenario document. A third example of being able to reuse unit tests is to, instead of running this test as a scalability test, to run it as a service monitor. I'm going to tell it to stop running this test. And actually, I'll just close this guy. And what I'll do is I'll tell it to open. And here's a service monitor. The service monitor has its own definition of a control panel, a controller panel. And here it is. So if I tell it to start operating, what this is going to do is now reuse those unit tests, but instead of running them like a scalability test where you've got a whole bunch of different threads going, instead it'll run those unit tests periodically. And I have this one set up. I think it's every 10 seconds it's going to operate. The service monitor then keeps on operating until it finds an exception, in which case it can notify you. The notifications can be by email, by SMS, you name it. It can also fire off a JMS request. It can even connect up to a relational database and do inserts into that database when it finds that the unit test is asserting an exception. So the list that you see here, I'll just drag this a little bit wider. The table that you're seeing here indicates which use cases operated, what the result was, where it was operated, because service monitors could operate on multiple test nodes on a network. And then this icon here indicates that the most recent test completed successfully. If it didn't, then you'd see basically an alert icon show up. And so what we find is that many IT managers will use the push-to-test environment within their data center, and they'll keep this service monitor basically up as a dashboard to indicate success or failure of their system to meet their users' needs. So let me show you how the test scenario document is used to reuse that unit test as a service monitor. So I clicked on the edit icon, and here is the XML of the test scenario document for this service monitor. Here's the basics information. It looks pretty similar, right? That's kind of the idea. It's repurposing these things from unit tests into service monitors shouldn't take any more effort than it did for me to create a scalability test. Here are the resources that are needed, and now here's a monitor definition. So in this case, it's going to say, monitor, run this basically every 10,000 milliseconds, every 10 seconds, and keep on running this until you encounter an exception. And then here is the test use case and the dimensions. And there's the run method, which is calling that unit test that I recorded using the TestGen for Web plugin. So with this environment, with the TestMaker environment, I didn't need to do any programming to be able to reuse a unit test into those three different types of tests: functional tests, scalability tests, and load and service monitors. So you might wonder, okay, well, that's great, but what else can I do with this? Well, one of the things that we found is that while the while recording web applications is certainly an important thing to do, there's a lot of work being done now within smaller organizations to adopt either REST-based services or SOAP-based services. And so what we've done in the SOAP front is to include the SOAP UI utility, which comes from everywhere. How many of you are familiar with SOAP UI? No, not yet. SOAP UI is really cool in that, say yes. No, say no. So SOAP UI is an open source, another GPL product for working with WSDL definitions of SOAP-based web services. So how many of you are working with SOAP? Yeah, just a few. OK, so I won't take too much time on this. The problem with SOAP tends to be that very few people really understand WSDL. You know, it's pretty hard to look at a WSDL document and turn that into a test suite, for example. And so what we've done is to integrate the SOAP UI utility because it allows us to do things like define a WSDL document. Like actually, I've got it already created here. And so this is a message service that PushToTest provides as an example. And if I wanted to take a look at its binding, I can see that it provides me with one service titled Echo Elements. And I can enter in a request. The request appears instantiated here as an XML document. This is a SOAP message envelope that will be sent to that service. And what the SOAP UI utility makes very easy is the ability to work with the XML content that's required as a request to the service, and then to see what the results are without having to do any heavy-duty coding. So here I'll say title, Frank/title. And I can click on this icon up here. This actually sends this SOAP request out to the service. And then you'll see over here is the response back from that service. And this being an Echo Elements service, all it's going to do is echo the elements that I typed in back to you. So in this way, I'm able to work with SOAP-based web services visually without needing to learn SOAP particularly well. And when I'm ready, I can create a test case, or a test suite, that will automatically call that Echo Elements function. So in this way, I'm able to author test suites visually and not have to worry about all of the details of encoding styles and parameters and XML schema definition documents. SOAP UI takes care of that for you. So if I switch back over here and tell it to open, I have a separate set of example test scenarios under SOAP UI examples. And so here is a load test. And if I open its XML document for the test scenario, here's the test scenario document. I've got basics information. I've got test nodes. So this looks familiar to you by now, right? And now if I scroll down, I can see this is a load test. And the run method that we've got, the run method says, hey, it's going to be called setup test, right? The test class itself is test suite. That's the name that we created in SOAP UI. The method that we want is called test case, and the language type is SOAP UI. So by doing this, I can now create a test of a SOAP-based web service and operate it from within the TestMaker environment, either as a functional test, a load test, or as a service monitor. And I didn't have to do any coding to get here. There's a few other things that I wanted to show off. For example, you might say, well, let's say I've got some performance results, and I wanted to do a comparison to see, hey, on a performance basis, is the current release faster or slower than the previous release? A question that I often ask, or I'm often asked. So here's the results directory. Here's the test that I created before. Oops, shoot. bummer. Let me just navigate back here. Example agents. Oops, not example agents. Results. And I'll click open. So we include a performance comparison utility, and I'm just realizing that I only ran that one test, so I don't have anything to compare it against. But you use this graphic utility to be able to add any of the results directories that PushToTest TestMaker has created. You identify which of the test cases that you want to operate on, and then you can tell it, give me a comparison of either the transaction time, the memory, the CPU, or the network that's being used, and it will show you comparison charts of each of these. Right now, I just have one run, so it's just showing it to me. But if I had, say, 2 or 3 or 4 runs, it would layer them one on top of another inside of this chart. So you can also take a look at the individual use cases that are available from each test node. So like, let's say you were operating the push-to-test environment across several different geographic areas, and you wanted to see, well, what's a comparison of performance between, let's say, people in China versus people in Europe that are trying to access the same server. With this environment, you're able to do that. There's one other thing I wanted to show you. I'm looking at the time, and I'd like to give you some possibility of asking questions. And that requires a chart. And I'm sorry for doing the chart, but I'm happy to come back and do a separate demo of our governance features. This is the push-to-test runtime architecture. What you see down on the bottom is typical kind of Web 2.0, Enterprise 2.0 application development environment, where you've got an application server that's speaking to a browser using, say, AJAX or RSS or HTTP or SOAP. You might have an email server that's speaking POP or IMAP. And so the push-to-test runtime acts as a test runtime. And it's not like an application server. It's more like a test environment. But you have a test runtime that can operate tests according to those test scenario definitions that we gave it. And those tests themselves are able to speak these multiple protocols. Built into the TestMaker framework is a library called Tool, which is our extensible protocol handler library. So out of the box, you get protocol handlers for HTTP, HTTPS, SOAP, XML, RPC, SIP. So if you wanted to test a telephony application, you could do that too. And then it's extensible so that if you had a custom protocol that you wanted to add to it, that gets put into the push-to-test framework and then operated from within those test nodes. I showed you before how we use the browser recorder and SOAP UI utility, but there's another way of calling the push-to-test environment, and that is calling push-to-test as a service itself. So push-to-test provides a SOAP-based web service interface so that a utility like webMethods, who has a X registry repository product, can call the push-to-test framework, have push-to-test operate a test, and then respond back with a result set which indicates the performance of the test, which errors the test encountered, and then whether the test was able to achieve certain performance metrics, like a certain number of TPS. All of that information is returned in what we call a GSRS document, Governance Statistics Result Set document. And that is then added back to the services that are managed within webMethods as metadata. So if you've ever used a repository, you'll typically see like a list of services. Wouldn't it be great if you could click on one of those services and see that it fails every Saturday, or it doesn't work well at night? These are things that you might be able to write code within your service consumer to avoid. We also provide an interface to DBA InfoPower's products, which are a database and application server monitoring and remediation solution, so that if you're using, say, Oracle in your application, you're operating a test within TestMaker, and Oracle seems to be the bottleneck to performance. This interface to the DBA InfoPower product will identify the hotspots of performance. As a matter of fact, we think that push-to-test is pretty much the only open source test utility that can really do a good job at kind of putting together the test results against what the actual back-end system is able to do. And we can do that through our GSRS and push-to-test as a service interface. So with that, I see it's about 10 minutes of 4, and it had about an hour, right? Let me open up. If anybody has questions, I'd be happy to answer them, or to try and answer them. Yes?
Do you have any numbers for performance impact and do you have any numbers on sort of what is the overhead for running push-to-test, and in particular for doing scalability? Is the push-to-test framework, does the performance scale with the number of tests you run, or?
It does. So what we typically recommend as a methodology for testing is to first build the test, or design the test and build it, but then to run oh boy, I'm blanking now. To run essentially a check of the system itself. The test nodes themselves obviously operate on individual machines and take up resources to use to operate the test. And so what we find is that we'll typically operate a test on the system itself to make sure that we're not maxing out, say, the CPU of the test node machines themselves. On a typical dual-core Intel-based server that has, say, 2 gigabytes of memory and has gigabit Ethernet, what we find is that in a SOAP-based web service test, we can typically get about between 200 and 300 concurrent requests on that one box. I'm sorry, not requests, but 200 or 300 concurrent virtual users. When you go to HTTP-based protocols, because there's so much less processing required to handle the XML, we find that we can go from 400 to 600 concurrent virtual users. And with the price of equipment nowadays, we find that, at least for the customer experiences that we had, that kind of scalability of the basic system is there. Did that answer your question? Yeah. So the way that the product is licensed, by the way, is that you can download the source code and build it yourself using the GPL license terms. Or if you download the pre-built and tested and installable software, it comes with its own installer, then we sell commercial licenses above 200 concurrent virtually running users. So basically that's enough for kind of a developer to write a test and to operate a functional test or a load test on their desktop. And then when it's time to roll that test into QA, they typically have a budget to provide support for the push-to-test framework. So it's not entirely free, but it is open source. Any other questions?
I had one. So I noticed that the results that push-to-test spits out, it's either proprietary or it's specific to, I didn't see any HTML sort of report. Is that something I missed? Or basically, number one, what do the results look like? And secondly, is it easily integratable into an existing test framework, for instance?
It is. So push-to-test is used often in continuous integration environments. The output can either be to the graphical console, as we saw before, and those test scenario documents, this one's just empty, and that's why it's just logging to the screen. You can also log to a relational database. All of the test results are stored in that results directory, which is here in XML form. There it is. So here was the results directory that we created. And so this is a log of each of the completed transactions. So you're able to then grab this with any of the data analysis tools like Hyperion and even Excel, and to continue analyzing the results. We also, did I say we log to a relational database? And then also we log to either JMS queues or to other message queues, so that you could have this as a live logging system into something that you wanted to build externally. And we publish the XML schema definition for the document.
Any other questions?
Good. Well, so I'm Frank at PushToTest.com. If you do think of a question after this, or if you have a particular application at Google, we'd love to see how push-to-test could benefit Google.
Thank you.
Thank you very much.